We here at 13 Projects were tasked to design a steel portal frame building in the Brisbane area that meets our client's design specifications. The client has asked for this portal frame building to be 32 metres long and 16 metres wide, with an eaves height of 10 metres and a roof pitch of 6 degrees. The rafters are required to support an 8 kN per metre load, and the final design is to have at least 10 windows and 2 doors, with one of them being a roller door. The portal frame structure is to be built on a 400mm thick concrete slab that extends past the building walls by 200mm and has a slab edge. An internal mezzanine is also requested by the client, which sits 4 metres off the ground with a floor space of 8 by 5 metres. The mezzanine level we have designed in our model is 11.1 metres long and 8.5 metres wide and is accessible by a staircase. It is supported by 7 additional columns and is lined with a 1.1 metre high railing as a safety precaution.
The following universal beams were selected as columns and rafters in reference to the One Steel Structural Steel catalogue. 7 portal frames were evenly spaced to fit the 32-metre building length. This spacing is crucial for the girts and purlins as they can't be manufactured longer than 12,000mm. The purlins were selected through the Lyside limited capacity table, with Z15012 being able to withstand inwards and outwards forces of 1 kN per metre. Purlin spacing was determined through the Cliplock Classic 700 maximum support spacing table to be suitable for Region B. Fascia purlins supplied by the client were also installed, allowing for future gutter installation if required. Similarly, C15012 was selected as the girts to support the same inwards and outwards forces as the purlins. The girt spacing was derived from the Spandeck Limit State Wind Pressure Capacity Table for Region B. Cleats in the form of gusset plates were used to attach the girts and purlins with dimensions of 100 by 150.8 by 8mm and 100 by 152 by 8mm respectively.
The portal frame design was modelled in SpaceGass using the Portal Frame Builder feature to analyse wind load cases and select appropriate beam connections. By selecting the B1 region for our portal frame design, SpaceGass was able to produce wind load cases appropriate for our Brisbane site. By completing a linear analysis and a buckling analysis on an isolated 2D model of an internal frame, we can understand if our structure is suitable for the conditions of this B1 region. As all of the members pass these tests according to Australian Standard 4100, the columns and rafters can remain the same and do not require any further adjustment. Similarly, the bolted apex connections, bolted end plate connections, and the pin base plate connections used in this structure all comply with Australian Standard 4100 and are suitable to use for this design. We can import the 5 primary load cases from the 3D SpaceGass model into this 2D model to analyse the combination load cases of the serviceability limit state and strength limit states. The displacement, shear force, and bending moment diagrams can then be used to provide further insight into our design.
Concluding the model, the external components were applied as per the brief. The roof cladding implemented is Lyside Cliplock Classic 700 sheeting, with a 0.42mm base metal thickness, a 40mm ribbed height, and has been installed to handle local weather conditions. Similarly, for the Lyside Spandeck wall cladding, the same thickness and installation considerations are applicable, but ribbed height is 24mm. 6 large windows are placed on either side of the structure, as well as 1 roller garage door suitable for moving vehicles and larger objects through, plus a standard single door is installed for foot traffic. Specifying these openings meets the client's requirement of minimum 10 windows and 2 doors with 1 roller door. These models have been developed by 13 projects considering all aspects of the design brief, whilst also ensuring that the design is feasible and able to withstand the environment it is constructed in.